Alright, so welcome back to this lesson, and now we are just left to create the last steps of our expressions, and after that the process is completely done. Before we move ahead, we'd like to add some few more things. The smoke from the fluid is going pretty much fine, but the only issue is that the smoke is just moving in an upward direction. Since we are using the buoyancy to 15, so obviously it will going to take to the y positive sections. What if we're gonna we want the smoke to move towards the x positive direction too, because our particle systems are also they are also getting affected towards that direction. So what we need to do is that we need to add some external velocity fields. So for that we need to select the fluid container and create the fields. Let us say we're going to use something called the air, and in this case particularly we don't need the attenuation and the distance, so we're going to use the 0, and we don't want to use max distance, so put that thing to the -1 or off. Okay, and of course we're going to use the direction to the x positive axis, and along with that we also want the dust to get settled down, so let's say minus 0.35 should also be a good start for that. Okay, the magnitude would like to go with the 40 to 45, depends up to you. And now it's been added to this one. So if you're gonna play the timeline, you should also notice that the fluid container is trying to getting itself managed to the surface of the mesh, where the speed of the particles could be more than 1. So this is, you may could say that some of the particles when they're trying to get settled because of the goal, they're just trying to catch some velocities, so which is affecting the fluid container. So again we're gonna do something over here. So let's say we're gonna open up the ash_goal and just start adding the expressions in the runtime before dynamics. Let's say after here we'll just start adding some few more lines, like the way we did with the particles as well. Alright, so if the speed is greater than 1, then ash_goal shape.fluid emitter 1 rate pp is equivalent to 1. And let's say if ash_goal shape dot die point is equivalent to -1, then the ash_goal shape dot die point is equals to time. Okay, the time would be the moment when the speed is greater than 1. All right, and then else if the time subtraction of the ash_goal shape dot die point, and in this case I'm going to give some a little bit bigger value as compared to the particles one. So let's say if it's greater than 2.5, maybe 2.5 to 3. Okay, then ash_goal shape shape ash_goal shape dot lifespan pp should equals to -1. Alright, and I guess that would be good. Let me just go through with the script again, so that I don't want to see any orange line over here. Oh, that's great. And now like you just noticed that when I was playing the timeline initially, the fluid was also getting the fluid emitter was just trying to catch over with those velocities of the particles that are greater than 1. Just to avoid that, we're going to add some few simple lines, and that is, let's say, and another condition, frame should also be greater than, let's say, 30. Okay, so all those values of the particles that are trying to get settled, they were going to get settled before the 30th frame. Okay, so there weren't going to be any problem. And the same thing you can use in case with the particles as well. Okay, so that would really going to be perfect, and we can click the edit. We can just close that up. And if I gonna play the timeline once again, I'm damn sure that the fluid emitter will going to respond before the 30th of the frame. Okay, it will gonna respond to you only when it will gonna cross the values after 30. And also, this is a very nice thing, after 30 the particle value is still settled. So after 35, when the speed is now getting affected just because of the the cache mesh is started moving, and all those gold particles are also getting adhered to it. So from that onwards, the fluid is showing the behavior. And with that, you could also see that there is a nice behavior inside the motion of the fluids, because the airfield is also affecting this one. I earlier thought that to give the negative buoyancy, but that effect wasn't coming great. The negative buoyancy will not really going to be the good thing, because this would be a kind of ash smoke. So it first need to be get rise up, and then it should get settled down. So for that, we had already considered the negative y-axis for the airfield. Okay, so with that, the process is very complete, and I really gonna like this stuff a lot. And I hope so that you should also have got the benefit of watching this stuff, and hope so that you're also going to use some great stuff inside your showreels. You're also going to come up with new different ideas of simulating a disintegration effect using the Maya, using the encloth, classic particles, and the classic fluids as well. Okay, so it's obviously nice time creating this stuff, and I hope so that this is clear, easily understood, and easily you can grab that stuff. And hope to see you again. Okay, bye bye, and take care of yourself.